Welcome to the flipped instructional session for Math 08B for Unit 609, More Pythagorean Theorem Applications. Our objective for today is to use the Pythagorean theorem to find lengths in two-dimensional figures. Just as a reminder, the Pythagorean theorem states that in any right triangle, the length of the hypotenuse equals the sum of the squares of the length of the legs. So a quick picture of that. Remember, a right triangle has to have one right angle. The hypotenuse is always directly across from the right angle. So here's the hypotenuse. It's also the longest side. And this is known as C. The legs are interchangeable in our formula and are known as A and B. And our formula is A squared plus B squared equals C squared. A cube has side length of 7 meters. What is the length of the diagonal of the cube to the nearest tenth? So if we had a cube, the diagonal, doesn't matter which diagonal, they're the same length, is from cross on the vertex here. So this is a right angle. So this makes a right triangle where the hypotenuse is here. So the diagonal, what is the length of the diagonal? Here's the diagonal. That's our hypotenuse, so there's our C. And our legs are down here, A and B. And a cube says it has length of 7 meters, so that's all the way around. So again, that's why it doesn't matter which way you do the diagonal. So we know that this is a right triangle, so A squared plus B squared equals C squared. So 7 squared plus 7 squared equals C squared. You need to be careful with this math. You need to do the exponents before the addition. So 7 squared is 7 times 7, so 49 plus 49 equals C squared. 49 plus 49 is 98. Then we need to square root to get C by itself. The square root cancels out that squared. So the square root of 98 is 9.89. Whoops, not C squared. It says round to the nearest tenth, so that's 9.9 meters. What is the height of an equilateral triangle that is 16 inches long on each side to the nearest tenth? So an equilateral triangle see if I can get it to look equilateral. So all the sides are the same. So each side is 16. So here's 16, here's 16, here's 16. It wants to know the height. So the height is straight down the middle here. This is the height of the triangle, which makes a right triangle. So we're trying to find this height. When we draw this down, this is actually called an altitude. When we draw this altitude down, that makes this cut right in half. So this is 8. So let's look at what we have. So we have a triangle where we have 8, H, and 16, and here is right angle. So the 16 is the hypotenuse. That's our C. We can use A and B interchangeably here. So we're going to say 8 squared plus H squared equals 16 squared. So let's take care of the exponents first. 8 squared is 64. 64 plus H squared equals 16 squared. 16 squared is 256. We're going to subtract the 64 because we're trying to isolate the h. So 256 minus 64 is 192. Then we need to get the h by itself. So we have to square root. So the square root of 192 is 13.85. It asks us to do this to the nearest tenth. That's one decimal place, so that would be 13.9 inches. So this is all the work that you need to be showing when you do those part 2 portions of the test. You need to make sure you have all of this work. You can't just put it all in your calculator and then circle 13.9. You need to see every step. A piece of wall art is made of 10 congruent equilateral triangles. The side of each triangle is 4 feet. What is the area of each triangle to the nearest hundredth? So it's just asking about one of the triangles, so that 10 is not really needed. So each side is 4 feet. So we have 4 feet, 4 feet, 4 feet, and it wants to know the area. Well, the area of a triangle is 1/2 base times height. So in this, we do have the base is 4, but we don't have the height. Remember, the height is right down the middle here. We don't have this height, so we need to calculate it. And we calculate it just like we did our last problem using the Pythagorean theorem. So now we have this little triangle. Here's our height. Here's 4. And remember that when we draw the height or the altitude, that cuts it in half. So here's 2. Here's the right angle. So the 4 is the hypotenuse. So 2 squared plus h squared equals 4 squared. Take care of those exponents. 4 plus h squared equals 16. Subtract 4. H squared equals 12. Square root. H equals the square root of 12, which is 3.46. It says to the nearest hundredth. So I'm actually going to go one further out. 3.464 because I want to round at the end. So I'm taking this one step out. So area, now we know, is 1/2 times the base times the height we just found. So when we multiply all that together, we get 6.928. So to the nearest hundredth is 6.93 feet. This is area squared. Remember, area has square units. A rectangular garden has a walkway along its diagonal. The garden is 80 feet long and 50 feet wide. What equation can be used to find the length of the walkway if x is the unknown value? So let's get I always think it's best to get our picture up here so we can label and then we're not guessing. So it's 80 feet long, 50 feet wide, and then let me get a line out this time. The diagonal, oh, it doesn't like that. There we go. Is right here. So remember, the diagonal is just opposite corners. So here's our right angle. So directly across is the hypotenuse, which they told us is the walkway. And they called it x. They want to call this x. So that's the hypotenuse. So that's what we put in for c squared. A squared plus b squared equals c squared. So we're going to have 80 squared plus 50 squared equal to x, because that's what they called it, squared. So that is D. So for more help on using the Pythagorean theorem Please come to the live session, Flip Follow-Up, or Help Lab, which you'll see on your Class Connect schedule. Thanks.